Think you know JavaScript? Prove it. 15 code challenges. 15 seconds each. Try to guess the output before time runs out. And don't worry, I'll break everything down at the end. Let's see how many you get right. Ready? Let's dive into the first challenge. What's the final value here? Let's start by looking at the variable a. The comparison is done using loose equality, which means that the left and right operands are converted to numbers before being compared. The string text cannot be converted to a valid number, so it becomes nan. True is converted to 1. Since nan is not equal to any value, even itself, the expression evaluates to false. So a is false. For the second variable b, we have a comparison using strict equality, which checks for equality without type coercion. The empty array is an object, while false is a boolean. Since they are of different types, the expression evaluates to false. So b is also false. Finally, we print the result of a and b. The logical and operator evaluates from left to right and returns the first falsy value it encounters. Since both a and b are false, the expression evaluates to false. What's the final value here? First, arithmetic operators have higher precedence than logical operators. So 1 minus 2 is evaluated first, resulting in -1, and 5 times 2 becomes 10. The logical and operator evaluates from left to right. It returns the first falsy operand, or the last operand if all are truthy. Any non-zero number is truthy. Since both operands are different from 0, the AND operator returns the second operand, which is 10. Watch closely, this one's tricky. Here we have a for loop that runs 4 times. Inside the loop, a function is scheduled using setTimeout to run after 100 milliseconds. This function will print the value of I when it runs. It's important to note that the loop uses var to declare the variable I, not let. The key difference is that var has function scope, not block scope. This means the same I variable is shared across all iterations of the loop. By the time the setTimeout callbacks execute, the loop has already completed, and I has the final value from the loop, which is 4, because the loop stops when the condition I less than 4 is no longer true. This is why all 4 callbacks will print 4. Another snippet for you. What do you think happens? This time we have a nested array which contains numbers from 1 to 4, but in nested subarrays. The flat method creates a new array with all subarray elements concatenated into it recursively up to the specified depth. The flat2 method flattens the array up to 2 levels deep and stores the result in a variable named flat. Now we modify the array. Flat.pop removes the last element, which is the array 4. Adding an array to a number converts the array to a string. So array 4 plus 1 becomes the string 41. 41 is then pushed back into the array. The final result is an array containing the numbers 1 through 3 and the string 41. Think you know what this logs? For this exercise, we have an object shopping cart with a property fruits, which is an array of strings, and a method show list. The key to understanding this code is how this keyword works. When shopping cart.showList is called, this refers to the shopping cart object. because it's being called as a method of that object. Inside showList, we call this .fruits. For each method to loop over the fruits array. The arrow function properly accesses and logs each item in the array. What happens when we run this? This time we have an object with a property count set to 0 and a method inc defined as an arrow function. In JavaScript, arrow functions do not have their own this. Instead, they inherit this from the enclosing lexical scope, that is, from the environment where the function is defined, not where it's called. Even though the arrow function is inside the object literal, it's still created in the global scope, because there's no surrounding function to give it a meaningful this. So this inside the arrow function refers to the window object in browsers, or the global object in Node.js. Line 4 tries to increase the property count of the global object, but since it doesn't exist, this .count returns undefined and then tries to increment it. JavaScript doesn't know how to add one to undefined, so it returns a special invalid number value called nan. At the same time, it sets this .count equal to nan on the global object. Because this .count is now nan on the global object, the line prints nan. Here's a quick brain teaser. In JavaScript, two strings are compared from left to right, character by character, based on their corresponding ASCII values. In this case, the only difference between the two strings is the last character. One important fact is that lowercase characters have higher ASCII values than uppercase characters. The ASCII value of lowercase n is 110, and the value of uppercase n is 78. Since 110 is greater than 78, the comparison evaluates to true. Can you predict what this will print? In this example, we have a string stored in the variable str. We use a for of loop to iterate over the string, meaning you can loop through it character by character using this syntax. On each iteration, the variable char takes the value of the current character in the string. Inside the loop, we call char dot to uppercase to convert the character, and then print it using console log. So the loop will print each character of the string on a new line in uppercase. What this console log will print. The logical or operator evaluates operands from left to right and returns the first truthy value it encounters. If all operands are falsy, it returns the last one. Let's evaluate each operand. The number 0 is a falsy value. Null is also falsy. The string contains a space, so it is truthy. 42 is also truthy, but the evaluation stops once a truthy value is found. Since the string is the first truthy operand, it's printed to the console. Guess the output in comments below before I show it to you. We've defined two variables, a which is 5 and b which is the result of 1 plus a plus plus. The a plus plus is a postfix increment, which means the current value of a is used first, and then it's increment by 1. So b is the sum of 1 and 5, and then a is increment to 6. In the end, when we print both variables, the output is 6 and 6. What happens when we run this? This code uses the Nullish Coalescing operator, which returns the right-hand value only if the left-hand side is null or undefined. In this case, credit is 0, which is a falsy value in JavaScript, but it is not null or undefined. Therefore, credit is returned as is. The final output will be 0. Take a look at this one. Can you figure it out? First, a constructor function animal is defined, which assigns a name property to each instance. The speak method is added to animal prototype, so all instances created using new animal inherit this method. A new animal instance named Rex is created and stored in a variable called dog. When dog.speak is called, JavaScript looks up the prototype chain and finds the speak method on animal prototype. Since this .name refers to Rex, the method returns, Rex makes a noise. Another snippet for you. What do you think happens? The function foo of x modifies the input by subtracting 1, but it does not include a return statement. In JavaScript, when a function doesn't explicitly return a value, it returns undefined by default. So, when we call foo of 2, the result is undefined. Then the code tries to evaluate undefined plus 9 that gives us nan. Here's your next puzzle. What will this output? JavaScript's ternary operator has the next form: a condition followed by a question mark, then an expression to execute if the condition is truthy followed by a colon, and finally the expression to execute if the condition is falsy. The first condition is 0, which is a falsy value in JavaScript, so we skip A and move to the false case. 0 is a non-empty string, which is truthy, and this evaluates to B. Alright, time for the last brain bender. First, let's look at the variable x. Even though 5 is a string, the subtraction operator only works with numbers, so JavaScript automatically coerces the string to a number. Thus x becomes 3. It's important to remember that the subtraction, multiplication, and division operators always trigger numeric coercion. They don't perform string concatenation. Now let's move on to the next variable. We have 3 times 2, the string gets coerced to the number 2, so that gives us 6. But then we add the string 2 using the addition operator, switching to string concatenation, and giving us 62. Finally, let's look at the last operation. Notice the unary plus before y. This operator converts a string into a number, so the string 62 becomes the number 62. So we're doing 3 plus 62, and the final result is 65.